Well, welcome back to Science 5. We have been pulling apart the world of matter. And do you remember the definition of matter? What is matter? Remember, matter is anything that has volume and has mass. Here's a few more things. Do you remember what volume is? Well, volume, remember, is the amount of space a substance takes up. And how is mass defined? Remember the amount of material in an object. Okay, so volume, how much space there is, how much it takes up, and the mass is how much material there actually is in the object. Two total different things, all right? So today we're going to further discuss matter and looking at how matter can change the current state that it is in. But before we look at that, let's go ahead and look at the three states of matter we talked about last time: solid, liquid, and gas. Which state, look at the chart, has no definite volume and no definite shape? Right, a gas. And the particles in a gas, remember, they are very active. Now, would helium, a chair, or glue be a gas? Helium would be a gas. Let's look at that chart again. What state has definite shape and definite volume? Right, a solid does. And there's a very strong attraction within the particles to each other, which keeps the particles very close together. Now, would we consider water, air, or a textbook to be a solid? The textbook would be a solid, all right? Let's look at that chart one last time. All right, of course, that leaves us with the last state of a liquid. And what are the properties of a liquid? It has definite volume, but no definite shape. And the particles in a liquid move more than the particles in solids do. The liquid takes on the shape of the container it is put inside of, all right? Remember, like I took the glass of water and I poured it into the bowl. It still was the same amount of water. It just took the shape of the bowl instead of the glass. Now, would a gumball, coffee, or carbon be considered a liquid? Of course, the coffee. Did you know that there are more than 3 states of matter? The 3 we talked about, of course, are the most common, and you learn about them practically every year in science. But there is a 4th state of matter that we learned a little bit last time called plasma. Let's learn some more about plasma.
If you apply enough energy to a block of ice, it melts into a liquid. If you apply enough energy to the liquid, it turns into a gas. And if you apply enough energy to the gas, its atoms split apart and the gas becomes plasma, the most common form of matter in the visible universe. Plasma is found in lightning, the northern lights, the sun, and all the stars. Think about those examples. You can't touch or taste any of them. That's because plasma only exists under extremely hot conditions. You'll find it in things like neon signs, plasma TVs, fluorescent lamps, and lasers. Scientists are still looking for more ways to use plasma. A lot of research is being done on using plasma as an energy source. If scientists succeed, maybe one day everything on Earth will be powered by plasma.
I hope you enjoyed that and learned maybe even something new about plasma. Today we're going to be focusing on the changing states of matter. Matter, we know, cannot be created or destroyed. God created all matter at creation and set it in order. We cannot create or destroy matter, but we can change matter from one form to another. When I say change from one form to another, do you know what I'm referring to? Changing from a liquid to a solid or a solid to a liquid. I have a pretzel with me up here. Well, actually several pretzels up here with me. But suppose let's say break this one in half. I'll probably break it. Oh, look at that, broken half. All right, is it still a pretzel? Yes. If I continue to crush it up and break it into pieces, is it still a pretzel? Yes, but it's smaller in smaller pieces than it was before. We call this what is a physical change, all right? I didn't change the item, I just changed the appearance of the pretzel. Before we continue, I think you probably would like to hear some interesting facts about pretzels. I know, random, but why not? They have nothing to do with their content, but I thought it'd be kind of fun to know a little bit more about them. I learned some things I actually didn't know. So let's take a look at some. Well, the first one is the average U.S. citizen consumes up to 2 pounds of pretzels per year. But Philadelphians snack on about 12 pounds of pretzels per person every year. So if you're from Philadelphia, you eat a lot of pretzels. President George W. Bush was munching on pretzels in the White House when he choked and lost consciousness while watching football. And then in Austria during the 16th century, pretzels adorned Christmas trees, meaning they were ornaments. I thought those facts were pretty interesting. Now, like I changed the physical appearance, made a physical change with the pretzels, I'm going to change the physical appearance of my clay or my dough, whatever you're going to call it. Now, if I take this ball of clay and press it hard and smash it, now the clay is in a different shape. It has not changed into something else or formed a new substance. It has just changed the form. We call these changes physical changes. All right, so let's define what a physical change is. Well, a physical change is a change that does not form a new substance. It just changes the appearance, like the pretzel and the clay did not change into something else, but they looked very different. Now, today we're going to be looking at 4 physical changes that can happen to matter, or 4 ways that matter can change its state. All right, I have up here with me a chalkboard, and I have a sponge, and I'm going to dip it in some water up here. You can't really see it, but I do have water. All right, and I'm going to wipe it, and we're going to come back to that. Okay, you can see the water on it. So we're going to come back to that in just a little bit when we talk about these changes in this lesson. Now, let's look at a preview of some of these different states. What are we going to be looking at? Well, we'll be looking at melting, freezing, vaporization, and condensation. The first one we'll be looking at is melting. I know it is an easy one that we are very familiar with. All right, here a picture of chocolate. Now, if I take chocolate and leave it out in the sun with, let's say, 95-degree weather, the chocolate will melt. The chocolate has not changed into any other type of substance. It is still chocolate, and I would still eat it. It may look different and feel different, but I guarantee it is still chocolate. It just changed the form and the state that it was in. It went from a solid to a what? A liquid. Now, when a substance changes from a solid to a liquid, we call it melting. Wow, no idea how they came up with that definition, okay? So let's define melting. All right? Melting is the process of a solid changing to a liquid. Okay, you can see the chocolate there that's being melted. All right. Do you think all solids have the same melting points? Of course not. Different solids have different melting points. What would happen if everything had the same melting point? Well, everything would melt at a certain temperature. That would not be good, all right? So let's look at a chart of some different melting points that objects have, all right? Well, ice melts, of course, we looked at earlier at 0 degrees Celsius. Lead melts at 328 degrees Celsius, and most metals have very high melting points, meaning that the temperature needs to be very hot, right? Glass melts somewhere between 1,000 and 1,500 degrees Celsius. Now, can you think of any examples of a solid changing to a liquid? Well, maybe putting butter on hot corn. The solid butter will melt into a liquid on that corn. Of course, matter can change states the opposite way. If I put a gallon of water in the freezer, it will not stay a liquid. It will change states eventually into a solid. This change is called, you ready for it? Freezing, right? Another very common one. So let's define freezing, right? Freezing is the process of a liquid changing to a solid. Very basic definition. Can you think of any examples of something we would freeze? We usually think of freezing as meaning something is cold, right? But actually in science, it is just any substance changing from a liquid to a solid. You could also call it solidifying. So let's use that example of chocolate again, all right? So after chocolate is melted, it is left to cool at room temperature. Do you know at room temperature, it will change back into a solid. It does not have to be frozen to change back into the solid state. The chocolate will solidify at room temperature. The point at which a liquid changes to a solid is called the freezing point. But don't let the word freezing throw you off, okay? It doesn't have to get cold to turn back into a solid. Now, the next changing state we're going to look at is vaporization. Vaporization is the process of a liquid becoming a gas. A liquid boiling when vaporization is occurring throughout the liquid and the bubbles of the gas rise and break away from the liquid surface, okay? Here's a picture of a pot boiling, or we have a tea kettle that the steam it's boiling, you can see it coming out. The point at which this happens we call is the boiling point. You've probably seen your mom boiling water or making rice or noodles, and you've seen the bubbles in the water and the steam rising from the water. A little bit ago, I wiped that chalkboard with water. Let's take a look at it. All right, there's still some water there, but it's not all still there. Was the water in any way boiling? No. What then happened? Where did the rest of the water go? Well, what happened is what we call evaporation. Evaporation is a form of vaporization. A substance evaporates when it changes from a liquid to a gas at room temperature. It only occurs on the surface of a substance. Now, it can be things as simple as wiping your kitchen counter for your mom. Does the water stay there? No, it goes away. Now we know what evaporate is. Now, the final change in matter we're going to look at is condensation. Now, I have up here with me a cool glass of water. And if you notice, there are, you can see little drops of water on the outside of my glass. I'll even wipe it. Maybe you can see the condensation. This is what we call condensation. If you have a glass of water sitting outside in the hot sun, the condensation will form. All right, so let's look at the definition of condensation. All right, condensation is the process of a substance changing from a gas to a liquid. Now, you may be thinking why this is important. Well, the condition at which a substance changes state is a physical property that helps scientists identify the substance. So let's review with a few questions. All right, let's look at them. First question, what two things determine a substance state of matter? The motion of the particles and the strength of their attraction. What are two ways gases differ from liquids and solids? Remember the properties of them. Remember, gases have no definite volume and can be easily compressed. Remember that example we did with the bread to show compression. All right. What is freezing? We talked about this today. Don't think of the temperature cold. Remember the process of changing from a liquid to a solid, or we call it solidifying. And then what is vaporization? What state of matter changes this? Remember, changing from a liquid to a gas. Make sure that you complete your assignment for this evening, and I will see you next time to continue talking about matter.